Welcome back. In this lesson, we're looking at evolution of AI ML history milestones future. AI/machine learning educational explainer. Now let's look at introduction. Artificial intelligence did not suddenly appear with chatbots and image generators. Its story began decades ago, with a simple but powerful question: can machines think? Over time, AI moved from rule-based programs to machine learning, deep learning, and today's generative AI systems. Machine learning changed the journey by allowing computers to learn patterns from data instead of following only fixed rules. This evolution has shaped search engines, recommendations, healthcare tools, finance systems, robotics, and modern digital assistants. In this video, we will explore the history of AI and machine learning, the key eras, major milestones, current impact, and future trends as of 2026. Now let's look at what you will learn in this video, January 2nd. In this video, we will cover. Now let's look at what you will learn in this video, February 2nd. What artificial intelligence and machine learning mean, the key eras in the evolution of AI and machine learning, the foundations of AI in the 1950s and 1960s, AI winters and rule-based expert systems, the rise of machine learning in the 1990s and 2000s, the deep learning explosion from the 2010s onward, the generative AI era of the 2020s, major AI and machine learning milestones. Year by year, current impact of AI and machine learning as of 2026, future trends shaping AI and machine learning. Now let's look at what are AI and machine learning. Artificial intelligence, or AI, is the broader idea of making machines perform tasks that usually require human intelligence. These tasks include reasoning, learning, problem-solving, language understanding, perception, and decision-making. Machine learning, or machine learning, is a major branch of AI. Instead of programming every rule manually, we train a model using data. The model learns patterns from examples and uses those patterns to make predictions or decisions. So, AI is the overall goal, while machine learning is one important method used to achieve that goal. Now let's look at the big picture of AI evolution. The evolution of AI can be understood through several major eras. The 1950s and 1960s were the foundation years, when early ideas, theories, and symbolic AI systems were born. The 1970s and 1980s saw both excitement and disappointment, including AI winters and rule-based expert systems. The 1990s and 2000s brought the rise of machine learning, where data and statistical methods became more important. The 2010s brought the deep learning explosion, powered by large datasets, GPUs, and neural networks. The 2020s brought the generative AI era, where AI began creating text, images, code, audio, video, and more. Now let's look at the foundations, 1950s to 1960s. The modern AI journey began in the 1950s. In 1950, Alan Turing proposed the famous question, can machines think? His idea led to the Turing test, a way to think about machine intelligence. In 1956, the Dartmouth Conference officially introduced the term artificial intelligence. Researchers believed that machines could be built to reason, solve problems, and use language. This era created the foundation for symbolic AI, early neural networks, and machine learning ideas. Now let's look at early neural networks and machine learning ideas. The late 1950s introduced important ideas that still influence AI today. In 1957, Frank Rosenblatt developed the perceptron, an early artificial neural network. The perceptron could learn simple patterns by adjusting weights, which is a basic idea behind modern neural networks. In 1958, John McCarthy developed Lisp, a programming language that became important in AI research. In 1959, Arthur Samuel used the term machine learning while working on a checkers playing program. These early breakthroughs showed that computers could improve through experience, not just follow fixed instructions. Now let's look at early optimism and symbolic AI. During the 1950s and 1960s, many researchers believed human-level AI might arrive quickly. Early AI systems focused on logic, symbols, rules, and search. The idea was that if human reasoning could be written as formal rules, machines could reason like humans. Programs were built to solve puzzles, prove theorems, and manipulate symbols. This approach became known as symbolic AI. It worked well in narrow problems but struggled with messy real-world situations. Now let's look at AI winters and a reality check, 1970s to 1980s. By the 1970s, early AI promises were much harder to achieve than expected. Computers had limited processing power, limited memory, and very little data. AI systems could solve small problems but failed when the real world became complex and uncertain. Funding reduced, expectations dropped, and the field entered what became known as an AI winter. An AI winter is a period when interest, investment, and confidence in AI decline. This era taught researchers that intelligence is much harder than writing a few logical rules. Now let's look at rule-based expert systems. In the late 1970s and 1980s, expert systems became popular. An expert system used rules created by human experts to make decisions in a specific domain. For example, a medical expert system could use rules to suggest possible diagnoses. A business expert system could help with technical support or decision-making. These systems were useful in narrow areas where expert knowledge could be clearly written as rules. But they were expensive to build, difficult to maintain, and weak when facing new situations not covered by their rules. Now let's look at why rule-based systems were limited. Rule-based systems had one major weakness: they could not easily learn by themselves. If the world changed, humans had to manually update the rules. If the system faced a new case, it could fail or give poor results. Real-world knowledge is often messy, incomplete, and uncertain. Human experts may also disagree, making rules difficult to define. These limitations opened the door for a new approach: machine learning from data. Now let's look at the rise of machine learning, 1990s to 2000s. In the 1990s and 2000s, AI shifted strongly toward machine learning. Instead of asking humans to write every rule, researchers trained algorithms using data. Statistical learning, probability, and optimization became central to AI progress. Algorithms such as decision trees, support vector machines, random forests, and boosting became popular. The internet created huge amounts of digital data. Better computers and more data made machine learning useful in search, advertising, speech recognition, fraud detection, and recommendations. Now let's look at data becomes the fuel of AI. Machine learning became powerful because data became widely available. Websites, sensors, mobile phones, cameras, and business systems created massive digital records. A machine learning model could study this data and find useful patterns. For example, it could learn which emails are spam, which customers may buy a product, or which image contains a face. This changed AI from rule writing to pattern learning. The more useful data became available, the more practical machine learning became. Now let's look at the deep learning explosion, 2010s to present. The 2010s brought a major breakthrough: deep learning. Deep learning uses neural networks with many layers to learn complex patterns. These systems became powerful because of three major factors: large datasets, faster chips such as GPUs, and better training techniques. Deep learning improved computer vision, speech recognition, translation, natural language processing, and robotics. In 2012, deep learning achieved a major breakthrough in image recognition through the ImageNet competition. This showed the world that neural networks could outperform older methods in complex perception tasks. Now let's look at image recognition and computer vision breakthroughs. Computer vision became one of the first major success stories of deep learning. Deep neural networks learned to recognize objects, faces, scenes, and patterns in images. This helped improve applications such as photo search, medical imaging, autonomous vehicles, security systems, and quality inspection. Before deep learning, engineers often had to manually design image features. With deep learning, the model could learn useful features directly from images. This made AI more accurate and more scalable for visual tasks. Now let's look at reinforcement learning and AlphaGo. Another major milestone came from reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns by trial and error. It takes actions, receives rewards or penalties, and improves over time. In 2016, AlphaGo defeated Lee Sedol, one of the world's top Go players. This was important because Go is a highly complex game with enormous possible moves. AlphaGo showed that deep learning and reinforcement learning could solve problems once considered too difficult for machines. Now let's look at the transformer revolution. In 2017, the transformer architecture became one of the most important breakthroughs in modern AI. Transformers use attention mechanisms to understand relationships between different parts of data. This made them especially powerful for language tasks. They could handle long context better than many earlier models. Transformers became the foundation for many large language models. They helped AI systems generate text, summarize documents, translate languages, write code, answer questions, and power chatbots. Now let's look at the generative AI era, 2020s to present. The 2020s brought the rise of generative AI. Generative AI systems can create new content such as text, images, code, music, speech, video, and synthetic data. Large language models became widely used for writing, learning, coding, analysis, and conversation. Image generation models made it possible to create visuals from text prompts. Multimodal models began working across text, images, audio, video, and documents. This era made AI visible to everyday users, not only researchers and engineers. Now let's look at foundation models and multimodal AI. Foundation models are large AI models trained on broad datasets and adapted for many tasks. Instead of building a separate model for every use case, one foundation model can support many applications. For example, the same model may summarize text, answer questions, write code, analyze images, and support chat. Multimodal AI goes further by combining different types of input and output. It can understand text, images, audio, video, and structured data together. This is a major step toward more flexible and general-purpose AI systems. Now let's look at AI agents and workflow automation. A major trend in the mid-2020s is the rise of AI agents. An AI agent is a system that can plan, use tools, follow steps, and complete tasks with some level of autonomy. For example, an agent may search information, summarize documents, draft emails, update records, or support customer service. Multi-agent systems allow different AI agents to work together on complex workflows. This moves AI from only giving answers to helping perform work. However, Agentic AI needs careful monitoring, security, boundaries, and human oversight. Now let's look at major milestones, 1950 to 1969. 1950, Alan Turing proposed the question of machine intelligence and introduced the idea behind the Turing test. 1956, the Dartmouth Conference formally launched the field of artificial intelligence. 1957, Frank Rosenblatt developed the perceptron, an early neural network. 1958, John McCarthy developed Lisp, a major programming language for AI research. 1959, Arthur Samuel popularized the term machine learning through his checkers program. 1960s, symbolic AI, theorem-proving, search algorithms, and early language systems became major research directions. Now let's look at major milestones, 1970 to 1989. 1970s, AI systems faced limits due to low computing power, limited data, and overpromising. 1970s, the first AI winter reduced funding and confidence in AI research. Late 1970s, expert systems began gaining attention in specialized domains. 1980s, rule-based expert systems became commercially important in business and industry. 1986, backpropagation helped revive interest in training multi-layer neural networks. Late 1980s, the cost and complexity of expert systems led to another slowdown in AI enthusiasm. Now let's look at major milestones, 1990 to 2009. 1990s, statistical machine learning became more important than hand-coded rules. 1997, IBM Deep Blue defeated world chess champion Garry Kasparov. Late 1990s and 2000s, support vector machines, random forests, and boosting became widely used. 2000s, the internet created large-scale data for training and testing machine learning systems. 2006, deep learning research gained renewed attention through deep belief networks and better training methods. 2009, ImageNet helped create a major benchmark for computer vision research. Now let's look at major milestones, 2010 to 2019. 2012, deep learning achieved a major ImageNet breakthrough with AlexNet. 2014, generative adversarial networks, or GANs, introduced a powerful way to generate realistic data. 2016, AlphaGo defeated Lee Sedol, showing the power of deep learning and reinforcement learning. 2017, the transformer architecture was introduced and changed natural language processing. 2018 and 2019, large pre-trained language models became increasingly powerful. By the end of the 2010s, deep learning had become central to modern AI. Now let's look at major milestones, 2020 to 2026. 2020, large language models showed major progress in text generation and few-shot learning. 2021, AI systems became stronger in code generation, protein structure prediction, and creative applications. 2022, ChatGPT introduced conversational generative AI to a global audience. 2023, generative AI adoption grew rapidly across business, education, software, and creative work. 2024 and 2025, multimodal models, AI copilots, and enterprise AI tools became more common. By 2026, the focus shifted toward AI agents, governance, security, domain-specific models, and reliable business value. Now let's look at current impact of AI and ML as of 2026. As of 2026, AI and machine learning are no longer only research topics. They are part of search, recommendation systems, smartphones, finance, healthcare, logistics, manufacturing, education, and software development. Businesses use AI for customer service, marketing, document processing, analytics, coding support, and workflow automation. Healthcare researchers use AI for imaging, risk prediction, drug discovery, and clinical decision support. Students and professionals use AI for learning, writing, summarizing, brainstorming, and productivity. At the same time, organizations are still learning how to scale AI safely, measure value, and manage risks. Now let's look at current challenges as of 2026. Even with rapid progress, AI still has important challenges. AI systems can make mistakes, produce biased results, or generate false information. Generative AI can create convincing but incorrect text, images, audio, or video. Businesses must manage privacy, security, copyright, compliance, and data quality. Model outputs often need human validation, especially in high-risk areas. The future of AI depends not only on better models, but also on better governance, evaluation, transparency, and responsible use. Now let's look at future trend 1, Agentic AI and multi-agent systems. One important future trend is Agentic AI. Instead of only answering questions, AI systems will increasingly plan and carry out multi-step tasks. Multi-agent systems may allow different agents to work together, each handling a specialized role. For example, one agent may gather data, another may analyze it, and another may prepare a report. This can improve productivity, but it also creates new risks. Organizations will need clear controls, audit trails, human approval points, and safety boundaries. Now let's look at future trend 2, domain-specific and smaller AI models. Another important trend is the rise of domain-specific AI models. Instead of using one general model for everything, many industries will use models trained or adapted for their specific needs. Healthcare, law, finance, manufacturing, supply chain, and education may all use specialized models. Smaller and more efficient models will also become important. They can run faster, cost less, and work on devices with limited computing power. This will help bring AI to phones, factories, vehicles, hospitals, and edge devices. Now let's look at future trend 3, multimodal and physical AI. AI will increasingly understand the world through multiple forms of information. Future systems will combine text, images, audio, video, sensor data, and real-time context. This will improve applications such as robotics, autonomous systems, medical analysis, education, and industrial inspection. Physical AI connects intelligence with real-world machines such as robots, drones, vehicles, and smart devices. The goal is not just to understand digital information, but to act safely and intelligently in the physical world. This will require strong safety testing and careful design. Now let's look at future trend 4, responsible AI, security, and provenance. As AI becomes more powerful, responsible AI will become more important. Organizations will need to know where AI-generated content came from and whether it can be trusted. Digital provenance, watermarking, model monitoring, and AI security will become more common. Regulations and internal policies will shape how AI systems are built and deployed. AI governance will become part of normal business management. The safest AI systems will combine innovation with transparency, accountability, and human oversight. Now let's look at final recap and closing. Let us quickly recap the journey. AI began with the dream of machine intelligence in the 1950s. It moved through symbolic AI, rule-based systems, AI winters, machine learning, deep learning, and generative AI. Machine learning shifted AI from manually written rules to learning from data. Deep learning gave AI powerful perception and language abilities. Generative AI made AI creative and accessible to everyday users. The future will be shaped by agents, multimodal systems, domain-specific models, physical AI, and responsible governance. The story of AI is still being written, and we are living through one of its most important chapters. To wrap up, here is the key takeaway. You now have a structured overview of evolution of AI, machine learning history, milestones, future. Review the core ideas, connect them to examples, and revisit concepts like introduction, what you will learn in this video, 1/2, what you will learn in this video, 2/2, when practicing. If you can explain the idea in your own words, you have really understood it.